Alright, so these are some examples on slides 19 and 20 of our Chapter 20 PowerPoint. Basically, these aren't necessarily example problems per se, but I wanted to go through and walk you through how to use oxidation numbers and how to assign oxidation numbers to specific elements in a compound using the rules. So on slide 18 are the 7 rules to assigning oxidation states. One is, in a compound, you want oxidation states to add up to 0, like compound is neutral, unless it's a polyatomic ion. If you have an element by itself or as a diatomic element, like Br2, oxidation state is going to be 0. If you have an ion, it's just going to be equal to the charge of the ion. What else? Let's see. Rule 4 says that groups 1 oxidation state is +1 and group 2 is oxidation state of +2. Rule 5 says that fluorine is a -1 oxidation state unless it's paired with oxygen or fluorine, and all of the other halogens have a -1 oxidation state. Rule 6 says oxygen typically has an oxidation state of -2, and Rule 7 says that hydrogen has an oxidation state typically of +1. So if we go back to slide 19, I have some elements and compounds written here for examples. So here we're just going to assign oxidation numbers to every element in the compound that's written. So our first compound is bromine, Br2. So according to basically rule 2 on our previous slide, bromine as an element, because it's diatomic, has 2 bromine atoms paired together, but it's an element in its natural state. Therefore, its oxidation number is 0. So that's going to be the case with any element by itself as long as it doesn't have a charge written. For barium 2+, our second example, this is following rule 3. So basically, our oxidation number is just the same as the charge that's written. It is +2. For carbon dioxide, this is our first compound. Here, we're going to use the fact that we always know what oxygen's oxidation state is to help us figure out what carbon is. So, this is incorporating a couple different rules. Rule number 1, the charges or the oxidation states of carbon and oxygen have to add up to 0 for a neutral compound. According to rule number 6, oxygen is always in the -2 oxidation state when it's with a compound. So that leaves us looking for what carbon's oxidation state is. So the way we figure that out is basically we have 2 oxygens that each have a -2 charge. That means they're contributing a total of -4 to the overall charge of the complex, or the overall oxidation state of the compound. So something plus -4 has to give us a total charge of 0. So this number right here is going to have to be +4. That means that carbon's oxidation state is +4. And oxygen, we've already assigned it, is -2. Since we have 2 of them, they contribute a total -4. And if you add +4 and -4 together, you should get 0. So for the fourth compound, aluminum oxide, we know oxygen always has a -2 charge. We don't know about aluminum though. So what we can do is we have 3 oxygens that have each a -2. for a total of -6. And we're looking for what we add to -6 to give us an overall compound charge of 0. So in this blank has to be +6, right? But notice we have 2 aluminums. So we're going to divide that 6 by 2 because we're splitting that total charge into the 2 aluminum ions, and we get +3. So aluminum's oxidation state is +3, and oxygen's oxidation state, since it's a compound, is -2. Alright, so for the next page, slide 20, here we're getting a little bit more complex with our examples. This first one on this page has now 3 elements with it. So we're going to use the fact that we always know oxygen to have a -2 charge, and hydrogen in a compound is always +1. And that's going to help us to figure out what chlorine is. So in this compound, we have +1 plus some number gives us, sorry, let me start over on that, because we have 3 oxygens. So we have +1 from the hydrogen. If we have 3 times -2 oxygens, that's a total of -6. So if we're adding them all up together, it's going to be +1 plus some number, we're trying to figure out what chlorine is, plus -6 gives me 0. So that number in the middle, in order to cancel out all the other charges and have them equal to 0, has to be +5. And that happens to be the oxidation state of chlorine. So hydrogen, +1, that's one of our rules. Chlorine, we had to figure that out, is +5. And oxygen, just a single oxygen, is -2. For the second example on this page, now we have, this is a polyatomic ion. We're trying to add up to this charge right here, 2-. So oxygen, we always know, is -2. We're looking for sulfur. So we got to figure out how much total charge oxygen gives to the compound. So 4 times -2 is -8. So here now we're looking for what plus -8 adds up to, and this time it's not 0, it's adding up to 2-, and that comes from the fact that that's the charge of our polyatomic ion. So what plus -8 gives you 2-, and that happens to be +6. So sulfur has an oxidation state of +6. Oxygen still -2. Because the oxidation state, it's not made on, it's made per individual element, not necessarily how much it contributes to the total charge. And then our last example, looking for the oxidation state of all these elements. Oxygen's going to be -2, hydrogen +1, and we don't know oxidation state of copper. It likes to change. So if we have 2 times +1 hydrogens, that means they contribute +2. Oxygen, there's only 1, so they're contributing -2. So if we add all these up together, what +2 plus -2 gives me 0. Now this, you'll notice, 2 plus -2 already gives me 0. So that means that actually the carbon in this case has an oxidation state of 0, because we already have a 0 charge sum if we do 2 plus -2. So carbon is 0, hydrogen plus 1, and oxygen minus 2. And there you have it. That's how to assign oxidation numbers to elements within a compound.